So guys, if I calculate molar mass of CH4, and if you look at carbon, carbon has a molar mass of 12 gram per mole, and you have got 4 hydrogens, each hydrogens 1 gram per mole, you add them together and you get 16. This is molar mass of CH4, or it's called formula mass as well. So 1 mole of CH4 is 16.0 grams. Can I say this is an equation? Both sides of equation are representing the other side. They're equal together. So if you have an equation, do you remember we said whenever you have an equation, you can write 2 unit conversion factors? We learned this in chapter 2. 1 unit conversion factor, you said every 16 grams of methane, which is on the top, is 1 mole of methane, or you can inverse this relationship. Every 1 mole of methane has a mass of 16 grams, so you have got 2 conversion factors, which is coming from this one equation. 1 mole of methane is 16 grams, you can write 2 conversion factors. So what is use of these conversion factors? Let's check. This is the active ingredient in vinegar. Vinegar is made of almost 5% acetic acid. This is the formula. This is the formula of acetic acid, C2H4O2. Can you calculate the molar mass first? Using the periodic table. Once you calculated the mass of 1 mole, molar mass, then from that equation, give me 2 conversion factors like we just learned. Go guys, open up the book, use the periodic table to calculate molar mass of C2H4O2. Wow, 4 participants. You are amazing bunch of students. Good job. Once you have the molar mass, give me 2 conversion factors, please. One equation, every equation can always give us 2 conversion factors. Give me the 2 conversion factors. Excellent. Good progress. You're doing very well. Do these make sense to you? That 1 mole of acetic acid on the top has a mass of 60 grams, and every 60 grams of acetic acid makes 1 mole. These are the 2 conversion factors you can write based on the formula, molecular formula. You have 2 conversion factors. Any questions?
So that you just got that by using the table, correct?
Yes.
Okay.
So next, this is the application of the conversion factors that you just learned, how to write them. But if I give you grams, you can use the conversion factor to get number of moles. So grams can be converted to moles. And if I give you moles, you can convert it to grams by using the 2 conversion factors that you just came up with. So grams and moles cannot be interconvertible. So let's go to the next slide. I'm going to give you an example. Guys, if I ask you how many grams of aluminum are there in 3 moles, can I say you are asked to convert moles to grams?
Yes.
Great. Thank you. So I have 3 moles. The unit is given in the moles. I want to write moles on the bottom to cancel moles. The question is asking how many grams. So I have to convert moles to grams. So what I'm converting to goes on the top of conversion factor. So grams of Al on the top, moles of Al on the bottom, and then I have to relate bottom to the top to the bottom. That's how we did in chapter 2. What is the relationship between mole, 1 mole of aluminum, how many grams? This is coming from table. Look at the table, find Al. Do you see 27.0 underneath? So that is mass of 1 mole. So what is the conversion factor suggesting? It's suggesting take the 3, multiply by 27, divide by 1, which is the same number, and you get 81.0. Can I say moles and moles are gone? Can I say moles and moles cancel each other? The unit left is grams. You write the unit here. So by defining conversion factors, which is deducted from molecular formula, you can convert moles to grams, or if I give you grams of Al, you can give me number of moles. Is this clear so far? Do you have any question? So let's go to the next slide. This is the formula of aspartame, artificial sweetener. How many moles of aspartame are there? How many moles are there in 225 grams? That means you need to come up with a conversion factor which cancels grams and convert this to moles. So the first step is calculate the mass of 1 mole using this formula and the table. Calculate molecular mass from the formula. Once you have that, come up with conversion factors. Use the one which cancels grams and convert to mole to get the answer. Go, guys. Let's see who is going to be the number 1 here on this question. Wow, 3 people are number 1. All 3 of them together. Wow. I'm so excited to see that you're paying attention and you're learning very fast. Do these make sense? Did you get molar mass of 294 grams per mole? You are given grams of aspartame and you're asked to give us moles. So you're canceling grams by writing it on the bottom. You're converting in moles by writing mole on the top. What is relationship between the top and bottom? 1 mole of aspartame, this is mass of 1 mole of aspartame, is 294 grams. So by using this conversion factor, can I say you can cancel grams of aspartame? Now you're converting to moles of aspartame. This is the right unit. What is conversion factor suggesting? Take 225 multiplied by 1, which is going to be same number, divided by the bottom, and get the answer. Do you get 0.765? 0.765 moles of aspartame? Do you have any question? Anybody? All right, you're doing very well. Guys, in our discussion, in our lecture last time, we said in a chemical reaction, atoms are not created and they are not destroyed. They simply break a bond and make a new bond. That means mass is not changed. Mass is conserved. We don't have loss of atoms or creation of atoms. That happens only in nuclear reaction. It happens at sun or nuclear bombs or nuclear reactors. Nuclear reactors are different from chemical reactions. Chemical reactions involve electrons only. Nuclear reactions involve very high temperature and they involve nucleus. So conservation of mass, what does that mean? It means add up the reactant. So in a reaction of reacting 2 moles of silver, I'm going to write solid here because this is the solid. Silver at room temperature is a solid. With 1 mole of sulfur, which is also a solid, as you see, it's a yellow powder, you are producing 1 mole of Ag2S. That's the chemical reaction. So 2 moles of silver, all you have to do, what's the mass we are using? 2 moles, each mole is 107.9 from the periodic table. This is the mass of 2 moles of sulfur. You're reacting it with 1 mole of sulfur. Look at the periodic table. You see sulfur. Underneath the sulfur, it says 32.0 grams. That's mass of 1 mole of sulfur. The total mass of all the reactants together is 247.9 grams. What about the mass of product? We're getting 1 mole of Ag2S. How do I calculate mass of 1 mole of Ag2S? Well, there are 2 Ag and there are 1 sulfur. I'm going to get 247.9 if you add 2 times this number plus mass of 1 sulfur, you get 247.9. So what you are starting with number of grams you're starting with, you end up with same number of grams as product. Masses are never destroyed or created in a chemical reaction. Atoms to each partner, they break a bond and they make a new bond. So this is one rule that you can use in doing chemical calculation. If you talk about mass calculation, you can use this. You can use law of conservation of mass to calculate mass of reactant or product, or one of the reactants or products, if you know the other ones. Any questions?